because this NAND is taller and thicker. Our thin reverse stencil is flat. The thing in the middle will rise when we press down. The purpose of padding paper towel is because it is soft. It can flatten the gap in the middle. It can depend on the thickness of the chip, just appropriate. Take out our thin reverse stencil. We must clean up. Clean it after every use. It is also cleaned with PCB water, because the flux on it can only be washed off by PCB water. After washing, observe if there is any dirt in the hole. Then tin planting. If you plant tin, you will also use tin paste. Let's take some tin with the flat blade. Because this blade is flat, you can use it to scrape tin. After getting a little tin paste, because the tin paste is very moist, the main reason is that it can be stored longer. So we have to absorb it moisture a little bit. Just take out the paper towel and press it to dry it a little bit. Don't soak it too dry, just a little bit moist. Then plant tin. In the process of tin planting, I like the reverse stencil and the point of the chip. Align first. After aligning, you can see that if my hand presses the reverse stencil on both sides, it will lift up like this. If this is the case, the side will be up like this. So that's why we need to pat paper towel. Press lightly like this. No special force is needed. Just press it with a little force. You can see it is flat. Don't press both sides. Just press the middle position. Demonstrate it to everyone. You can use your hand like this in this position. Don't use too much force. It will be provided by too much force. Just fix it gently. Then apply tin paste. Wipe on it gently, not very hard. Wipe every place evenly and wipe every place, because it needs tin everywhere. When you wipe it all over, remove the excess tin. After showering away, take out a new dust-free cloth. Do not use the used. Wipe gently on the surface to wipe off the excess tin. Take out the curved tweezers at this time. Just press both sides and fix it. It doesn't need too much force. The temperature of planting tin is 270. The temperature depends on how fast the chip tin melts. If you want to go faster, you can adjust it to 360 degrees. We blow. When it becomes a thin ball, you can immediately close the gun without blowing it at all. At this time, the thin paste hasn't solidified yet. Don't move it yet. Dry it with your mouth. Blow it cool. Cool it. After blowing it down, you can see that the thin paste is now solidified. Remove the revolve stencil. You can see that this is what we just revolved. It is not very beautiful now, so add some soldering flux. Here is a piece of cotton to get it off. It won't affect. Then we clamp it and add a little solder flux. After adding soldering flux, reset the thin point. We can clamp it up like this and reheat it. You can see that the tin has melted. Okay, that's it. Then wait for it to cool. The temperature of planting tin is actually not very uniform. If you want to be safer or similar, there is no problem using 270 degrees. Because the melting point of tin paste is 180 degrees. We use 270 degrees to blow it, is no problem. 300 is also no problem. 500 is fine. 500 degrees can quickly solidify the tin. But this requires a little skill. The risk is higher. So generally use around 270 to 300 degrees. As long as it forms a thin ball, we can close the air gun immediately. Don't wait for it to form a solder ball and blow it at the same place, otherwise it will damage the NAND. Next, install the NAND. This is the part we have processed. Then there is another kind that doesn't look flat enough or how. We can use the suction tape to continue taking it off. This is the suction tape we just used. There is too much tin on it. Cut it off. After cutting it off, fold it like this to suck more. No need to cut too many times. Still the same, NAND requirements are not as high as CPU. So there is no problem if you don't deal with this. Now flatten this. Actually, there is no need to take it off. Almost it is enough, because the hard disks have relatively large point, so the requirements are not so high. In fact, it can be installed directly like the case just now. Okay, this way is very flat. We still use cotton to clean, because the flux is all, the flux we have used is cleaned directly. Must be cleaned, no vinyl residue. For example, if there is glue on foreign objects in this position, when installing the NAND will be lifted up, lead to poor contact between soldering joint and soldering joint. Next, add some soldering flux when installing the NAND, only a little. That's it. Then take the tweezers. They must be clean. You can wash it with PCB water. Then it is okay to flatten the PCB water like this. You can spread it or not, because Some can flow here, so you can spread it. Okay, after the start, we put the NAND that has just been planted with tin in the correct position on it. Then many people will ask how to distinguish this direction. First of all, it will have a red dot or A1 corner on our schematic. For example, if this is a 6S NAND, we can see that the corner on this schematic is A1 corner. Then there will be a red mark at this position on the drawing. The point that proves it is facing this position. In this case, the direction will not be installed wrong. Then we align it. It doesn't matter if a dot as big as the NAND is not aligned properly, because the NAND is very large. If it is a small chip, we will talk about it in the next class. This class only talks about NAND. It is okay if a point is as big as a NAND, but we try not to do this. We just have to align it slightly, even if it is crooked, because it will automatically return to its position when it is combining between tin and tin. So we are now heating and blowing. Do not use 360 when blowing, because the low temperature tin has been changed. The wind speed is 45. The temperature increased a little, and it can be increased to 320 degrees. If you want to go faster, 360 degrees is okay, but you have to master the temperature very well. If it is safe, 320 degrees is enough, because we use a melting point of 180 degrees for tin planting. So we use 320 degrees to heat it is enough. And the air gun used 8mm big air nozzle. Because you use a big nozzle when you just remove the NAND, you can also use a big nozzle now, because the NAND is relatively large, so use the big nozzle. Use big mouth for disassembly, but to remove the glue, use the middle mouth, because the glue does not need to use too much area. During the reheating process, we must keep making circular motions to make it evenly heated. You can see that it moved automatically, and it's proof that its melting point has been combined. At this time we touch it lightly, it has returned to its place. You can move the NAND like this because the NAND is relatively large. I want to show everyone, so I blew it for a long time. You don't need to blow for so long. As long as you touch it like this, it will have a rebound action. Need to close the air gun immediately, because it was just a demonstration, so I didn't close it so quickly. If you do it to rebound, you have to stop the air gun heating immediately. Okay, wait for the motherboard to cool down before moving the motherboard. If you move the motherboard without cooling well, it may cause it to a right place. Because it has not solidified, the welding is not strong. Wait for about 30 seconds to 1 minute before moving the motherboard. That's it this class. See you next lesson.